In this video, we focus on a very basic problem in PDEs. We have this function u depending of x and t, which is e to the minus 8t times sine 2x. And we want to show that this is a solution to this boundary value problem. This is the one-dimensional heat equation. Here I have homogeneous Dirichlet boundary conditions for x0 and x equals pi. And here for t equals 0, I have that the function becomes sine 2x. The first step is to check the boundary condition. Check the boundary conditions. So I take my function and I put x equal to 0. And I have e to the minus 8t times sine 2 times 0. And this is equal to 0. Now I check for x equals pi. And this also gives me 0. So from here, this boundary condition at x0 equals with the boundary condition at x equals pi. So my function is 0 for these values. So these boundary conditions are satisfied. Now I have to check this boundary condition here for t equal to 0. So for t equals 0, what I get is just sine 2x. So the boundary condition for t equals 0 is satisfied. All boundary conditions are satisfied. Now the next step is to check if my solution, if this function that I have here satisfies the PDE. What I have to do is to find the first derivative with respect to t, then the second partial derivative with respect to x, and see if this PDE is satisfied. The partial derivative with respect to t of this function is the following. It's partial derivative with respect to t, so I differentiate only this term here, is minus 8 e to the minus 8t sine 2x. Now I go to the right hand side and I have to calculate. First I calculate the first derivative with respect to x of the function u. So this is 2 times cos 2x. Now I calculate the second derivative. calculate the second derivative with respect to x. Which gives me minus 4 e to the minus 8t sine 2x. So from here, uxx equals minus 4 e to the minus 8t sine 2x. U of t equals minus 8 e to the minus 8t sine 2x, and uxx equals minus 4 e to the minus 8t sine 2x. If I take 2 times uxx is minus 8 e to the minus 8t sine 2x, and this gives me u of t. So from here I have partial u with respect to t equals 2 second derivative of u with respect to x. So the PDE is satisfied. Boundary conditions and PDE. Consequently, the function u of x comma t e to the minus 8t sine 2x is solution to the boundary value problem.